Okay, Advanced Algebra 2. This is the start of our wrap-up session, we'll call it. We're going to go back and look at each chapter. We'll do one a day. We'll at least do 4 chapters this week. Today we'll look at Chapter 7, which we looked at the relationship between rational form and radical form. So again, rational form means fractional exponents. Radical form, you've got that radical bar in there. Okay, and if you remember, the one thing you have to remember when you have a fractional exponent, to convert it to rational form, look at where that denominator goes. That denominator went in the hook. Okay, so if we have 5 to the 2 thirds power, how would we convert that? Well, 3 is our denominator, so that means we're doing a third root of 5 squared. And you also have a little bit of freedom with that square. You could either put it inside on the 5, or remember, you could put it all the way outside, whichever way helps you the best. Okay, so I'm just going to review some of the highlights of the chapter, and then you'll have, I think today has 5 questions for homework. You may have to go flip back through some old notes, or search around YouTube, search around the internet, what have you. Because all the examples, everything I go over in the notes may not be everything that's on the worksheet. You may have to do a little research on your own. Okay, so let me clear that out and do a couple little examples here for you. So if we have something that is in rational format, fractional exponents, and we want to convert it over to radical form, we know that these denominators would go in the hook, and they're different right there. One is a 3 and one's a 2. It's 1/3 power and 1/2 power. So the first thing we need to do is they need to be the same denominator. So we got to do a little common denominator work here. What would be the common denominator from 1/3 and 1/2 would be a 6. So we would change these to a 6th as a denominator, which would mean we would have a 6th root eventually in our answer. So 1/3 times by 2 to get 6, so that would be 2/6. That's going to be an x squared inside that radical. Y the 1/2 power would be the same as y the 3/6 power, and then it would be a y cubed. And then we have converted it to radical form. Okay, got to have that same denominator so that we can have one single root in that hook up there. Okay, then if we're in radical form and we have to do some simplifying, we did a lot of this work in this chapter. Remember, there's a difference here, outside and inside. Outside on this one's a 1, and inside. And our first step is simply to do outside times outside. We get 2x. Inside times inside, we would get 3x to the 4th. We would be adding our exponents on those variables there. Then we just simply have to simplify. This is a square root. Okay, so remember, you're looking for dates, pairs of 2. If we have 4 x's in there, how many pairs of 2 do we have? We have 2 pairs of 2. So the square root of x to the 4th is an x squared. So that gets simplified to x squared, and then we would take 2x times our x squared times the square root of 3, and we get 2x cubed times the square root of 3 as a final answer on that. Also in this chapter, we did some functional notation work. F of x, g of x, functional notation, and just a quick little synopsis there of what this is. Remember, it's just a fancy way to write your equation. You know, remember, what would f of 2, what would that make you do? What would you do with your 2? You would plug your 2 in for every variable in f, and you would get 2 plus 5. You would get an answer of 7. So we'd be able to say f of 2 equals 7, which again, an added piece of information we learned is that 2, 7, the coordinate 2, 7 is on our graph. Okay, so that's one thing we can do with functional notation. Another thing you can do is you can add them. Remember what that would look like? There's a fancy way to say add f of x and g of x. There's a fancy way to say subtract f of x of g of x. As a matter of fact, let's do the addition. If we add, what would f of x plus g of x make us do? Well, it would just simply make us take x plus 5, which is f of x, and add 3x minus 1, which is g of x, and then we just simplify. What will we get here? 4x plus 4. Okay, so that's just a different way to write a problem. The other thing with these we did are the composites. Remember that? I'm not even going to say it out loud yet. Remember how to say that? How you say f of g of x, f of g of x. Now, we just did f of 2, and we took that 2 and we plugged it into f. We would do the same thing here, only it's not a 2. This just simply means we take g of x and we plug it into f. What is g of x? 3x minus 1. So that's like the 2, that we just did. We're going to take that and plug it into f of x. So f of x used to be x plus 5. We're going to take this x out of there, and what gets put in its place? Whatever g is, 3x minus 1 plus 5, and then we just clean that up, and we get 3x plus 4. So f of g of x is 3x plus 4. And of course, it could be flipped around, and you would just do the same thing but the other direction. You would take f of x, you would take x plus 5 and plug it in to g. Put it right where that x is, multiply both of them by 3 and subtract 1, and so on. Okay, so that's just a little refresher on some things I thought we needed to refresh in Chapter 7. We'll kind of do this every day. This week also the homework will be multiple choice, and I will have a Google form where after you do your homework you'll have to go in and input your multiple choice answers, and it will grade it for you so you know if you've gotten it correct or not. You will not have to submit a picture. You just have to complete the Google form. Okay, so this is Monday. See you tomorrow.